Good afternoon, everybody, and welcome to the latest BCS Author Webinar Series 2025. I'm Ian Borthwick, Head of Publishing at BCS, and I'm joined today by Stephen Mariadas and Ian Huke, authors of Data Science Foundations, to go through a presentation on data science and storytelling, more of which we'll get to in a second. So this is the latest in our series of author webinars. We do have more of these webinars coming up in September. We've got a couple which are really focusing on AI and digital solutions, and we will be adding additional webinars towards the end of the year. What we're doing is making sure that they're all listed on the Eventbrite, so I'll be posting that link into the chat, and we're also adding all the recordings to a YouTube channel, and I'll be adding that to the chat. So this webinar will be recorded and it will be posted online probably within about a week of finishing the webinar itself. The book will also have a link added as we're going along, and we'll be offering a special promotion on it later on as well. So we are doing questions and answers for this session, so please feel free to use the Q&A tab. I will indicate where it is in a minute through the system, so you'll all be able to see it. And there will be some interactive polls also as we go along, which Steve is running. So just watch out for them. They should be really good fun to get us engaged in. Yeah, so as I said, there'll be some links in the chat. You can use the chat. We will be dealing with any kind of relevant questions along the way, but if there are other questions, we will hold them for the Q&A just to make sure everyone has a chance to, ask about the process, but also ask about any kind of key data science questions they have that we can get to later on. Okay, so without further ado, I'd like to hand over to Stephen and Ian to provide us a bit more information about themselves and about their presentation today.
Hi everyone. So I'm Ian. Thanks very much for joining. Appreciate it. It's kind of interesting because I was looking at some of the people who are coming on and seeing some of the organisations and the descriptions there. And obviously there's a variety of people from different backgrounds coming on here. And I guess actually I came from a different background into data science, and a lot of people do. I actually started out life as a solicitor and then got involved in technology through building legal systems. As a result of that, kind of moved into business analysis, got involved in governance, and as time went on, became more and more involved in data. And I'd often be sitting there thinking, am I missing something when I was looking at it? And I really wanted something that would give me kind of a wide perspective that was easy to engage with, and kind of struggled to find something. And that's really kind of where the idea for this book came from. So that's me, Steve.
Thanks, Ian. Yeah, so it's really good to see everybody this afternoon. What better way to spend a Tuesday lunchtime than talking about data? So a little bit of background about myself. I've worked in industry for 15, 16 years before switching into education. And over the last 5, 6, 7 years, I've really seen a growth in the requirement for data skills amongst organisations, employers, and then subsequently within training providers, colleges, schools. Now, one of the things that my background in industry gave me was an understanding of actually what does it really take to implement change and use of these models. So it's all well and good talking about master's degrees and PhDs in data, but there's some real fundamentals required when you look at data and getting the impact of that into an organization. So for me, following on from Ian's kind of motivation to help write this book together, it was about not just talking about data science and the models and the maths and statistics. It was about making sure we're grounded in what does it actually take to make one of these projects or one of these answers to data science work within an organization. And that's kind of the flavor of what we've come up with today. The session we've called the Rock Pool. So we've come up with a fictional situation, and we would like to tell you a story. The stories are a theme for our presentation today, that this is not just about numbers. and machine learning and AI, etc. This is about telling a story that's going to be accepted by the audience, that's going to make a difference within a particular organization, or in this case, a different environment. So the rock pool is set in an ocean somewhere, and we have some characters to introduce. These characters, I'm sure you can quickly relate to other people within your organisations. And what we're trying to not do is make this industry specific, but I'm sure you'll tell through the story there's definitely some climate change and environmental underlying tones within this story. So without any further ado, let me introduce you to the rock pool.
Okay, so we have our first question up here. Question about Casey. Should they investigate this further alone, or should they work with others? Okay. And I think you'll find a poll in the chat function. So if you'd like to go there and vote, that would be brilliant. See what people think. Anyone else want to? A couple more people submit. Okay, so Oh, we're getting a bit of a divergence of opinion here. So some people are saying working with others, and others want to investigate alone. Okay, a couple more responses coming through. I guess kind of like, it's one of these questions, isn't it, where there's not necessarily a right answer to it. The survey, as we can see, predominantly people are thinking about working with others, but there are some advantages with working alone. You can set your own direction, you can set your own pace, and you don't have other people kind of interfering with kind of what you want to do and what you want to achieve. But I guess there's downsides as well. And we have the downside is that you are limited to your own skills, knowledge, and experience, and what you can bring into your project. And bringing other people's ideas in and bring other people's skills in can be really, really important, especially around kind of when you're using tools, like understanding them, validating your approach, so how you are going to do this, and also kind of the outcomes of your models. So that's the kind of technical side of it. But picking up on Steve's point of earlier, there's the human side of it as well. There's the ability to get support in what you're doing. And also, what really important is to get that kind of expertise around the domain you're working in and the problem you're looking to deal with. And sort of, I think, as we've sort of alluded to earlier, that data science draws on a wide range of disciplines, and a lot of different skill sets to be considered there. So I don't know, Steve, brilliant. Perfect timing, Steve, in terms of moving through the slides. Thank you very much. So I think it's worth thinking a little bit about the roles in a data science project. And, I think on a small project, one person may play all or many of these roles, but it's worth kind of thinking through what they are and what they actually bring to the project. So we'll just pick out a couple of them here. So we kind of have the sponsor. This is the person who's really setting the direction of the project, bringing the resources together to kind of make it happen. Okay, and then we have the subject matter expert. So we talked a little bit about understanding the knowledge and the domain of the problem space in which we're working. So they're two really kind of key roles. The other thing with a data science project, you do need data. Okay, and often, you will need someone to go and gather that data or work to be done to gather that data, and that can be a really big part of the project. And I think in the book we've got a couple of case studies where we look at the challenges people have in capturing that data. And one example, I think they spent over a year looking to actually bring the data sets together to just start trying to build models from it. So it could be a really key role. And then at the kind of heart of this model, we've got the data scientist who's creating and kind of analyzing the model. So some of the key roles there. It's also worth thinking about some of the other things that need to be done. And I think if you look at the life cycle of a data science project, you'll see that preparing the data is really important. And people like sort of data engineers and data technicians are people or roles that might assist with that. And then, of course, we've got this whole question as we go through about making sure that we are compliant with regulation and policies and ethical use of the data. So we've got the whole compliance piece in there. I think sort of, again, we can focus a lot on technical skills when we look at data science projects, but one of the big things, and something I hope we bring out through this, is the importance of communication and engaging with people and bringing people with you on your projects. And, I think we need to recognise that can be quite hard at times. And, working on building those relationships to kind of help that communication can be really important. So just some thoughts there. I don't know, Ian, if there's any questions anyone's raised around that, or anyone has any questions they want to put in the chat around that before we continue.
No new questions at the moment, so I think we're good to go.
So on that cliffhanger, we have another poll appearing in the chat. So I'd be interested to hear your views on, in this situation, time is obviously critical. And again, there's no right answer to this, but what are your views? Should we improve the data or should we carry on regardless? Oh, I thought this was going 50-50, but we're starting to get slight weight behind improve the data. Just time for a couple more votes. Again, please don't worry, there is no right answer to this. It's just your thoughts on where would you go in this situation? Okay, so data quality. It's something that anybody that says our data quality is perfect, our organization spends lots of time on this and we have no issues with our data. They're probably pulling your leg. I'm not going to use any harsher words than that. Data quality is something that we'll always encounter as a potential issue in what we're doing. But the number one place that people go when they think of data quality is initially into the accuracy of that. Have people entered the wrong things? Do we have missing data? Do we have duplicates of data? These are all the immediate that you can see within a data set. But data quality goes a lot further than this. When you're looking into data quality within an organization, the accuracy is just one element that you should worry about. And because it's the most obvious, it's the one that you should probably steer people away from because that's going to be their natural place to look. There are two other things that we really ought to consider when we're looking at data quality, and one of those is the latency of that data. So in our situation in the rock pool, yes, we could go get some more measurements. We could go look at gathering more data to add to the ones we've already got. But how quickly we need that data is important. It's all well and good looking at last week's data, but if things change radically within a week, is last week's data any good to you anymore? It might be the cleanest, no duplicates, no missing data, but completely irrelevant if time has moved on and makes things all look fresh again. So how latent your data, how long it takes to get that data and be usable is critical to the thinking about data quality. So those that said improve the data, that could be about checking for duplicates, filling in the blanks, interpolating values. But you have to question, how long is it going to take to improve the data? Are you going to move into a phase where it's not quite as important? Is the rock pool going to run dry before you finish taking your measurements? The other element is lineage. So where does your data come from? How did it get there? And this can be made even more complicated. You might know the source of the data. It might be a user entering the data into a system. It might be gathered by sensors. But normally, data will go through a journey within an organization. And along that path, there may be changes that happen to that data. So you've been told that it's been gathered from a sensor's one thing, but if it's been through three systems on the way to your spreadsheet or your data model, have there been any calculations? Have there been any roundings? Have there been any changes to that data along the way that may affect the answer that you're going to get as you go through the process? So knowing how your data has traveled through your organization is also critical. Now, in summarizing that, the data quality, please don't just focus on the immediate accuracy of the data, the things that you can see, touch, and feel within the data. You need to consider the timeliness and the origin of that data too. Now, before we move on to our third element, I'm just going to open up for if there's any questions or comments that people have.
I think we're steaming on
We're steaming
without
on.
questions at the moment, so let's carry on.
This is good. There's no latency here. We'll endeavour to move on the urgency of our rock pool and how it's going to work. So in the poll, you'll see our next question when we're going through our data journey. Now, in the modern world of machine learning and AI, more detailed, more complex models are easier to access and get hold of and use. But they come with downsides. In a situation in your organization or in the rock pool, should we go for a simple model or a detailed model? This one really is splitting the group a little bit more. So we have, at the moment, 70% on simple, 72% on simple, 75%, and 25% on detailed. So, simple or detailed models. Again, this comes back to the actual fundamentals of what a problem or a model can do within an organization. So there's lots of question marks about how we can use data, and then the results that we can get from that. In the modern world of data science, there's lots of options for models. And the number one thing I see when I'm talking to students or apprentices about using data science is they can understand how a model calculates figures. They can use tools and systems to help them calculate those figures. But when is the right model the right model? So in a situation such as our rock pool, if we were to do a simple model where we track over time what the water level is by day, we can get a response, and there's just an example in the slide there, that shows a pretty standard story of the water is going down day by day. The advantage of a simple model is that it can give us a very easy to view story, most of the time relatively quickly. It's also, when you think about this from a stakeholder perspective, if they can understand the model and kind of get a feel and some security in, they know what those figures are and they know why it's showing that a lot of the time a stakeholder will be more willing to buy into the story that that data is telling. Now, the other option is to use more complexity, to use more data. In the world of big data and machines that can process big data, why not have statistical models that could be more accurate, that can use that plethora of data available to you? So for an example, on our rock pool, we could use that simple linear model, or we could go for something like an ARIMA model. Now, a ARIMA model will use several different pots of data to come up with a trend in what's happening over time. And in this situation, we'll use things like moving averages, we use regression. So we will look to fit a model to the data that's given to us. And then we'll use that model, if it fits the data we already have, to try and forecast or predict what's going to happen with time. These models, as I mentioned, are more accessible than ever, especially in the world of cloud computing and AI. You can almost just throw data and ask somebody else or something else to calculate the outcome from that. But the big message that we would like to bring home around this is if you don't understand why a model should be used and the impact it will have with your stakeholders, then the purpose of doing the data science and the purpose of doing the model could be taken away. It could be less effective and less believable within an organization. So picking a simple or detailed model is not as straightforward as what you can do. It's more of a question of what you should do. And that starts to bring in more complex things like people. Now, at that point, I don't know, I think we have a question. Just looking through the chat, I think Angela's got, have we any tips in balancing data, up-to-date data with accurate data, especially as you often provided answers quickly? Well, the top tips are, unfortunately, it's a bit Blue Peter. For me, the things that work when we're trying to balance data is almost, here's one I did earlier. So Having a simple model with a result from it, and maybe you have to do extra work in comparing that to accurate data beforehand. If you know the impact of accurate data is not quite as big as it otherwise would be, you can start to try and lead or recommend to people that, yeah, the 80-20 rule is okay. If we've got 80% of our data, it's likely to give us the right message. But there's no silver bullet for that. There's going to be a grey line where things are effective or not effective, and that will again depend on who you're talking to. Ian, I don't know if you've got anything to add to the.
Yeah, I think it's a bit of a risk question, really. Obviously, it depends upon what you're going to use the data for, and when you put it into any particular model, what kind of risks that's going to present. And then I think you have to weigh up kind of actually, is this going to bring benefit? If it is going to bring benefit, how do I have to communicate kind of, the provisos around it? And, it may be, it may be that you do some initial work with that, but then actually articulate what additional value you'd get by having more up-to-date data. But I think about the risk of it and then talk to people about it.
Okay, thank you, Ian. I don't know if we've any other questions. Please do feel free to use the Q&A or the chat. That's fine. Okay, so moving on, the rock pool.
Okay, everyone. So question is, how do we go about doing this? Should we kind of explain the data, or do we want to tell some kind of story? So that poll's open, and I see people are voting there. So put your opinions forward and let's see what people reckon. Always quite a strong trend to tell a story. Anyone for explaining the data? So we've done the analysis and we're not necessarily going to explain the data. Okay, so we've got 100% there in favour of telling the story. Now, I think that this, to an extent, depends on your audience, okay, and what they will relate to. So if you're thinking about sharing this more widely, then maybe telling the story is the right answer. But if you're sharing it with a bunch of data scientists or mathematicians, then actually explaining the data might be the better way to do it. So let's just compare those two approaches for the moment. So if we explain the model, we kind of tell a story, or we kind of explain what we did. So, we investigated future water levels. We measured the water levels over a period of time. We developed a model. The model made a prediction, and therefore, the rock pool will dry up in a year. Okay, and that would work well probably with a technical audience. But I have to admit that I agree with everyone when they're saying tell a story, because in terms of communicating more widely, and we'll find out how that goes. But and there's a model for stories and is worth thinking about. So the concept of sort of setting the background, thinking about what's triggered the story, in effect, what's found out, what people realize as a result of it, and then the action they take. Right, and you can apply that to lots of things, but you can also apply it to your kind of data science projects. So if we just flip on the next slide, we can just have a look at this story in that relation. So if you look, if you think about the narrative we've had so far, you've got the daily life, and you've got a comment here about telling the hero's journey, and absolutely that's one of the pieces used. And there's obviously in this story there's all that jeopardy there. Okay. So if you think about communicating to people, and making them realise, like we've set the scene by sort of setting out the current state, the daily life. So we've talked about what the rock pool is like, and then we put the trigger in, the thing that has caused the analysis to happen. So you've noticed the water is falling. Okay, and then we've gone on to the analysis has shown that we are losing water, and the realization comes about that we need a new home. Okay, which leads to the action, which is mobilization. Okay, and so in effect, you are focusing more on the outcomes of what you've found than the actual technicalities of what fits behind that. And obviously, you can then drill into that for people if they want a more technical explanation. And you can think of this in in different different ways for different audiences. Okay, and I think that if you think about the kind of user experience, so the receivers of the audience, can they relate to this? Is it something that they can understand and on the back of have meaning to them to act? Okay, so in terms of questions around this, I think the point we're trying to make here, because I've noticed the questions coming up around the scientific methods. So this is about explaining the outcome to a non-technical audience, which is really where we're bringing up the story here. So it shouldn't be impacting the methods you use. I don't know, Steve, is there anything you want to add to that question that's come up there?
No, I'd agree. So, Monica, it's a great question. We're absolutely, don't get us wrong, we're not saying avoid scientific method. It is absolutely the right thing to do. What we're trying to advise is the scientific method in some situations will put a number of stakeholders off. So it's the right thing, but whether you need to go into what the hypothesis was, what the significant value was, and those kind of measures, with some stakeholders, if you start mentioning those things, they'll go, I don't understand that, therefore I don't understand the results. So it's about being careful, knowing who you're talking to and what's going to work for them at various points in the life cycle.
Any other questions around that? Right, well, we'll move on to our final part of the story then. Oh, but yes, I would suggest that you are able to evidence your conclusions. Absolutely, great point, Tom.
Yeah, but apart from anything, the reputation you have, if you've come and it's almost feeling the weight of the model, so you probably wouldn't print it out, but if you could show something that looks quite complex, for some people that will absolutely add believability to the work you've done, and integrity of the work you've done. So having it at hand is a good point, Tom.
Hey, should we move on to the story then?
Yeah. So the cliffhanger. So all's well that ends well. Use of data can lead to positive outcomes. Just a bit of kudos to Angela's comment in the chat about the source of data and whether there's somebody interfering with that data. Thank you, Angela. It is the school holidays. So just to add, whilst this was a happy ending, and they used data well to tell a story and to get action on the back of that, data science and use of data within an organization should always come with the caveat that many times it will probably tell you what you already know. So using that kind of concept of it's going to tell you something radically different that's going to change the direction of the organization and the way everybody's working, and it's going to do something very novel, most of the time is not the case.
I think it's worth adding there, again, in the book, there's a case study where the organisation spent a year. They first of all had to work out how to gather the data, and then they spent a year gathering the data, and then they found that they couldn't actually get any meaningful outcome from the data. And they were very positive about that in terms of recognising that they'd looked at a problem their clients had, they'd used data to try and solve it, and they'd worked out how not to do it, but they'd given them ideas about how to do it. And I think that's a really important point, that if you get your data and you analyze it and it doesn't tell you something new, or you can't prove what you were hoping to prove, that is telling you something, and that is valuable. And often people, disregard that, and they feel they have to have something as a result of it that tells them something new or gives new insight or is more radical in relation to it.
Super. Well, thank you both very much for that, and for moving us on to the Q&A slide. An interesting story. And just as a quick first note, I'd like to just quickly ask how you prepared it, and where's the credit lie for some of that storytelling.
I'm going to leave this one to Ian, even though he's on mute, because it was Ian's story originally, but I'm sure the source won't be too surprising for people.
Yeah, so basically we have to give credit to ChatGPT, Claude, Gemini, not Gemini, I can't remember the name, Gamma it's called, for doing the graphics. And I can't remember what you used, Steve, to get it to read. So basically it's very much AI supported, and underlying that obviously is all the data science that goes into AI. The original idea, it came from the fact that Steve lives down south and had probably gone down to the beach on a lovely sunny day, and paddled in a rock pool. That's where the inspiration came from. But a lot of the story writing was done that way. And I think it's kind of really interesting about how those tools can be used. I did a similar kind of piece several years ago where we told a story and had interactivity. And the time it took to prepare that compared to this was significantly larger without those tools. I think it also gives us it gives us insight into the fact if you look at the story carefully, you will find discrepancies in it, and inaccuracies in it, which is obviously a risk when you are using AI. And I think there's a voice change partway through, again, because we use technology and we had some challenges with it, Steve. So that's where the story comes from. So the original idea is human, and it was kind of directed by a human, but a lot of it was AI generated, and the AI, I think, did a really good job of doing that.
And it was overseen and edited by yourselves and accepted the results, which I think was something. But yeah, it's kind of an interesting case in point of being able to illustrate stories with something else. Yeah, and actually get through it. And I thought the polls actually were very, very useful and interactive. We do have time for some questions if there are anything else that people would like to add in. In the meantime, I will ask one question, and it's like, so assuming you're not starting out in already data science role, what like how would you go about applying data science like within your role? Like how do you spot like where it fits, how you could use it? So whether you're a business analyst or project manager or a similar, how would you potentially look at how it could be used?
Sorry, do you want to go first, Steve?
No, well, I was going to say the first bit, that's probably very easy. Data can always be used. We're surrounded by data, and being able to use it is one of the fundamental skills, I think, of anybody in a workplace. Gone are the days where data literacy is optional. Everything we do is measured. The amount of data we gather is phenomenal. Being able to use that data in your day-to-day job, it shouldn't matter whether your day-to-day job is just data or whether your day-to-day job is something completely different. Data literacy is critical in the modern age, and having access to AI and systems that can do a lot of the hard graft for us, it's even more important to be literate about what data can do and how it can tell us a story.
Mm.
So I think it's just worth referencing back to in the book. There are some case studies by real organisations who've been using data science, and when we were putting the case studies together, we asked them, okay, what would your advice be to people starting out in the field? And I think, the advice was very much about, get out there and experiment, try stuff, see what works, see what doesn't work. Someone said, what, find something you care about, you're passionate about, and find some data on it and apply that. There's lots of free tools out there that you can use to, to do that. And I think that's really the advice, like get something you're interested in, get some data and give it a go.
Nice, thank you for that. I don't really have any other questions off the top of my head because that was a really good starter question. You've covered quite a few along the way. I guess one question might be in terms of when you start using data science, and in particular, the scientific method, how scientific does one need to be, and how does one learn more about the right way of creating a hypothesis to test out using data? With the view also here, you mentioned using different kinds of tools to get results, to better understanding and verifying the actual results you're getting from use of tools, particularly if you're not running the statistical analysis yourself.
I think it's coming back to some of the points from both the book and the presentation. Having that expertise, that domain knowledge within the organisation is critical. If you're just starting out on your data journey, but you have that expertise of what's going on in the company, you're 80-90% of the way there. You'll know whether that data is relevant to what you're doing and what sort of message and results will impact on that organisation. If you're new to an organisation and you're new to data, it might be a little bit stereotypical, but yeah, dig out the domain expert. They've probably been there a little while. They'll understand the way the company works. Getting their sense check on that data that you're thinking about using, what's likely to come out of this, and that modelling is absolutely critical. So yeah, understanding the situation and understanding how it would impact the organisation is crucial.
I think there's also something about understanding the models you are using, because there are a lot of models out there. There are very complex models out there, and sometimes you talk to students and you think you don't really understand this model. You've taken it because it's been seen as a model that will deal with this situation, but you maybe don't quite have the understanding of it that's required to use it. Even simple statistical tests have different criteria that you have to meet for their use. So I think it's really good to be aware that different models will work with different data to demonstrate different things. And it's when you're starting out, taking those simple models, understanding them, and then being cognizant of that as you go through and start, maybe looking at more complex models to make sure they are an appropriate model for what you're doing.
Excellent. And so I think you cover model selection in the book as well, and kind of cover what kind of models would you cover off in the book as well? Is it just mathematical, or are there additional kind of application models or others that people may be looking to use?
Well, the models are fundamentally mathematical, but there's different types of modeling we can do. So we talk about prescriptive analytics, we talk about decision analytics, we talk about predictive. So one of the big changes 7, 8 years ago, through the 90s and the noughties, companies got very good analyzing data for things that had already happened and coming up with different versions and views of that data. Where the switch has happened over the last decade or so is that accessibility to these models that can also lead to prediction of what's going to, so forecasting what's going to come next. I mean, look at the Amazons, the Netflixes of this world. They don't rely on what's happened before. They will prompt you. They will know what you want to watch. They will use models that take it to what's going to happen next. So that's the big step for many organizations. Is going not just from give me a simple view of what's happened before and how performance has been. It's where are we going? What does this model tell me about what's potentially going to happen next?
Yeah, and the book covers some of those models and talks through. I think it gives some quite good explanations, and that's Steve's doing, not mine. Quite good explanations of how these models actually, in theory, work. So it covers things like classification, time series, regression in that respect. And I think it is interesting about how organizations use models. And it is also quite interesting that some organizations are asking questions that they're deciding not to answer because the cost of creating the model and the processing power that it costs is too much. So it's quite interesting to see that kind of behavior coming through now.
That's really interesting. I was thinking about an example I'd heard of through my partner who's worked in different organization. They had different models. One was a model you could basically take a snapshot and say, well, this is the current situation, but it didn't actually give you any feeling for what's going to happen. If that keeps happening, what happens in the future, and how do you monitor those different things happening and make sure you have a really good idea of being able to update your snapshot effectively and then look at what it means in the future. And we've got time for, I think, Sheila's question of could AI help with modeling?
Absolutely. But as we've kind of said, as we've been through this, whilst the presentation, and neither Ian nor myself are going to say we can make pictures and drawings of that quality off the top of our head. You have to be very careful. AI is an assistance to what's been done. Being able to sense check it, put some reality around it, and understand and kind of audit the results that come out of AI is really important. So AI will being able to build a model in Excel, those days are kind of passing us by now. AI will run a model, we can throw the data at it and get it to come up with some results. But knowing the right model, knowing when it's appropriate, knowing the impact of it, and sense checking the results are going to be the key skills going forward.
And I think that comes to transparency. So if you are running an AI model, you really want to make sure that it's going to be able to justify what it's come up with on it. And I think a lot of people maybe are using AI more for the data preparation now. And I guess I'm thinking generative AI here, as its kind of mathematical skills continue to kind of advance.
Yeah, I take caution with generative AI and mathematical skills at the moment based on some of the results I've seen out there, but there are different kinds of AI modeling which may be useful.
Absolutely.
In particular, different models are able to augment existing data sets and be able to get you insights on them, and then what you do with them after that you have to be actually more careful when you start to regenerate it. Just ask Dr. Who anyway. Ian.
Yeah, and I was going to say, I think the mathematical space is one to watch, because I think Microsoft recently announced sort of some strides it made or purportedly made in that space. But definitely whatever you're using, make sure that it can explain to you how it's got to where it's got to, so you can validate it.
Very good. Excellent. If we can roll on one slide, please, Steve. So we have been talking with Ian and Steve about data science foundations and the processes within the book, and also thinking about model selection and being able to really get your data quality in the right place and start to get your models in the right place as well, and actually give you the story, outline it for your audience, and help you to actually make an impact at work, use it to create action plans and then deliver change. So I think that's really a key role that the book holds. So there's a link in the chat, which I will try and emphasize for everybody, that you can get a discount on the book for the rest of the week if you buy it through the bookshop. So please do jump in and have a look at that. I've just dropped it into the chat again. Now it's available in print and in ebook format. There are other formats available through different platforms depending where your preferred, obviously, book purchaser is. The discount is only available through the BCS bookshop itself. If you roll on the final slide, please. And now, yes, well, we reached the end. So thank you very much, everybody, for attending. Thank you very much, Steve. Thank you very much, Ian, for presenting today and giving us an insight into what happens in the wilds of the sea in rock pools across the world. And again, thank you very much for all attending, and look forward to seeing you in the future at the next author webinar. If you have any queries or anything that you need to follow up on, please don't hesitate to contact BCS Publishing through our website or via publishing@bcs.uk. Always open to new ideas and new queries that you may have. So thank you all, and have a good rest of the day.
Thanks very much.
Cool.